Hi folks, this is Karim Raouf from IT Visualizer channel. Today we'll continue our Lambda Matrix lab. It's the video number 123. We have been discussing in the previous video the following. We have been still working with the topic of troubleshooting Windows using remote tools. We have discussed one of these remote tools, which is command shell commands. And in the previous video, we are exploring other remote tools like PowerShell remoting, SSH, some commands that are used for remote troubleshooting of Windows. We have seen how Claude had explained this non-GUI remote tools. We have seen them explained in simple terms, and today we will have some hands-on exercises on these different remote tools, how we can use them, some examples, and then we will, after finishing these hands-on exercises, we will see a learning dialogue to explain these different remote tools. So let's start from where we have stopped the last time. This is hands-on exercises for remote Windows management. Let's see the exercises. So here you go. Let's read out loudly.
Hands-on exercises for remote Windows management. This guide provides practical exercises for each remote management tool. Set up a test environment with at least 2 Windows machines before beginning. Prerequisites: a workstation running Windows 10, 11 Pro or Enterprise. At least 1 test server or VM running Windows Server, ideally 2 to 3 machines. Administrative access to all machines. Network connectivity between all systems. Exercise 1. Basic PowerShell remoting setup. Objective: configure PowerShell remoting and establish your first remote session. Steps: enable PowerShell remoting on your test server. PowerShell. Copy. Hashtag run on test server with admin privileges enable PS remoting force. Verify the WinRM service is running. PowerShell. Copy. Get service WinRM. Test connectivity from your workstation. PowerShell. Copy. Test WS-Man computer name. Test server 01. Establish a remote session. PowerShell. Copy. Enter PS session computer name. Test server 01. Run basic commands in the remote session. PowerShell. Copy. Hashtag these commands run on the remote server hostname. Get service get process sort object property CPU. Descending select object first 5 exit PS session. Expected outcome: you should be able to connect to your test server and run commands remotely. Troubleshooting: if test WS-Man fails, check that the server's firewall allows WinRM traffic. Verify both computers are in the same domain or workgroup. Try using IP address instead of hostname. Run WinRM quick config on the target server if issues persist. Exercise 2. PowerShell remote management tasks. Objective: perform common system administration tasks using PowerShell remoting. Steps: retrieve system information from multiple computers. PowerShell. Copy. $computers equals test server 01, test server 02. Invoke command computer name $computer script block, PS custom object, at computer name equals $env. Computer name OS version equals GetSim instance class name, Win32 underscore operating system. Caption last boot time equals GetSim instance class name, Win32 underscore operating system. Last boot up time, free memory GB equals math : round, GetSim instance class name Win32 underscore operating system. Free physical memory /1 megabyte. 2. Processor count equals GetSim instance class name Win32 underscore computer system. Number of logical processors, format table auto size. Find and manage stopped services that should be running. PowerShell. Copy. Invoke command computer name test server 01 script block. Hashtag find automatic services that are stop services equals get service where object $_start type EQ automatic and $_ status EQ stopped. Hashtag display the services $stop services select object name display name status start type hashtag optional. Start a specific service from the list hashtag start service. Name service name here. Check disk space across multiple servers. PowerShell. Copy. Invoke command computer name $computer script block get PS drive PS provider file system where object $_ free. And all select object add a name equals computer name. Expression equals $NV. Computer name name and name equals total GB. Expression equals math : round $_. Used /1 GB plus $_ free /1 GB 2 and name equals free GB. Expression equals math : round $_ free /1 GB 2 at name equals free %. Expression equals math : round $_ free $_ use plus $_ free asterisk 102 sort object. Computer name name format table auto size. Remote file management. PowerShell. Copy. Hashtag create a remote session $session equals new PS session computer name test server 01 hashtag create a test file locally. This is a test file. Out file path c:\temp/test file. The txt hashtag copy the file to the remote computer copy item path c:\temp/test file. The txt destination c:\temp/. To session $session hashtag verify the file exists remotely invoke command session $session script block get content path c:\temp/test file. The txt hashtag clean up remove PS session $session. Expected outcome. You should be able to gather system information, manage services, check disk space, and transfer files between your workstation and remote servers. Exercise 3. PSExec remote tasks. Objective. Use PSExec to perform tasks that can't be accomplished with PowerShell remoting. Steps. Download and prepare PSExec. Download PSExec from the sysinternals suite, Microsoft's website. Extract to a folder, e.g. c:\tools. Add this folder to your path or change to this directory in your command prompt. Run a basic command with PSExec. Batch. Copy. Sexec / test server 01 IP protocol configuration /all. Execute a command with elevated privileges. Batch. Copy. Sexec / test server 01 scmd/c. Echo this is running as system c:\temp/system_test.txt. Launch a remote interactive command prompt. Batch. Copy. Sexec / test server 01 icmd. Batch. Run a GUI application remotely. Batch. Copy. Sexec / test server 01 iEvent4.msc. Expected outcome. You should be able to execute commands and launch applications on your remote test server using PSExec. Troubleshooting. If connection fails, ensure the admin $share is available on the target computer. Check that your account has administrative privileges on the target. Verify Windows Defender is not blocking PSExec. Make sure file and printer sharing is enabled on the target. Exercise 4. SSH for Windows. Objective. Configure and use SSH for remote management of Windows systems. Steps. Install the OpenSSH server on your test server. PowerShell. Copy. Hashtag run on the test server add Windows capability online. Name OpenSSH. Server 0.0.1.0. Start and configure the SSH service. PowerShell. Copy. Hashtag start the service start service SSHD hashtag set to start automatically set service name SSHD. Startup type automatic hashtag confirm the firewall rule is enabled GetNet firewall rule name SSH. Connect from your workstation. PowerShell. Copy. SSH administrator at test server 01. Run PowerShell commands via SSH. Bash. Copy. Hashtag from your local systems administrator at test server 01. PowerShell. Command get service where object $_ status. EQ running select object first 5. Transfer files using SCP. PowerShell. Copy. Hashtag create a test file, SSH test file. Out file path c:/temp/SSH_test. TXT hashtag copy to remote server using SCP c:/temp/SSH_test. TXT administrator at test server 01 c:/temp/. Expected outcome. You should be able to connect to your Windows server using SSH, run PowerShell commands, and transfer files using SCP. Exercise 5, WMI/WMIC remote tasks. Objective. Use WMI and WMIC to gather detailed system information and manage remote systems. Steps. Query basic system information. Batch. Copy. Mix/node. Test server 01. Computer system get manufacturer. Model. Name. Number of processors. System type. Check installed hotfixes/updates. Batch. Copy. Mix/node. Test server 01 CFI list brief. Monitor CPU and memory usage. Batch. Copy. Mix/node. Test server 01 CPU get load percentage /node. Test server 01 OS get free physical memory, total visible memory size. Find installed software. Batch. Copy. Mix/node. Test server 01 product get name, version. Manage services remotely. Batch. Copy. List all services in their states mix/node. Test server 01 service list brief. Check a specific service mix/node. Test server 01 service where name equals spooler get name, state, start mode. Restart a service, be careful. Mix/node. Test server 01 service where name equals spooler call stop service /node. Test server 01 service where name equals spooler call start service. Expected outcome. You should be able to retrieve detailed system information and manage services using WMIC. Exercise 6. Remote registry management. Objective. Safely query and modify the registry on remote computers. Steps. Make sure the remote registry service is running on your test server. PowerShell. Copy. Invoke command.
So let's continue, guys.
Invoke command computer name test server 01. Script block. Hashtag check remote registry service get service name remote registry select object name status start type hashtag started if need if get service name remote registry status any running start service name remote registry set service name remote registry startup type automatic query registry values remotely batch copy reg query / test server 01 / hklm / software / Microsoft / Windows nt / current version /v product name reg query test server 01 hklm software Microsoft Windows NT current version /v current build. Create a test registry key and value. Batch. Copy. Regadd test server 01 hklm software test reg key /fregadd test server 01 hklm software test reg key /v test value /t_d hello from remote registry /f. Verify the new registry value. Batch. Copy. Reg query test server 01 hklm software test reg key /v test value. Clean up the test key. Batch. Copy. Reg delete test server 01 hklm software test reg key /f. Expected outcome. You should be able to query registry values, create test keys, and modify registry settings on a remote computer. Troubleshooting. Ensure the remote registry service is running on the target. Verify you have administrative permissions. Check for firewall rules blocking RPC traffic. Exercise 7. Remote file operations with Robocopy. Objective. Use Robocopy to synchronize files and folders between systems. Steps. Create test directories and files. PowerShell. Copy. Hashtag create local test directory with files no item path c:\temp robocopy test. Item type directory force1. 5. For each object, this is test file $_ file path c:\temp robocopy test \file $_txt. Hashtag create destination directory on remote server invoke command computer name test server 01. Script block new item path c:\temp robocopy destination. Item type directory force. Basic file copy operation. Batch. Copy. Robocopy 2 /temp robocopy test test server 01 $, /temp robocopy destination /e. Copy with logging. Batch. Copy. Robocopy $temp robocopy test test server 01 $teken /temp robocopy destination /e/log /temp robocopy _log txt. Mirror directory. Be careful with /mir in production. Batch. Copy. Add another file locally echo additional file c:\temp robocopy test \file 6.txt. Mirror the director Robocopy c:\temp robocopy test test server 01 $c$temp robocopy destination /mir/log plus c:\temp robocopy _log.txt. Delete a file locally del c:\temp robocopy test file 5.txt. Mirror again. Notice file 5.txt will be removed from destination Robocopy c:\temp robocopy test test server 01 $c$temp robocopy destination /mir/log plus c:\temp robocopy _log.txt. Verify the files on the remote server. PowerShell. Copy. Invoke command computer name test server 01. Script block get child item path c:\temp robocopy destination. Select object name. Length last write time. Expected outcome. You should successfully copy files to the remote server and understand how the /mir option synchronizes directories. Exercise 8. Scheduled tasks management. Objective: create and manage scheduled tasks on remote computers. Steps: query existing scheduled tasks. Batch. Copy. Tasks/query/stestserver01. Create a simple task on the remote computer. Batch. Copy. First, create a simple batch file on the remote computer echo at echo-off c:\temp\remote_task. Simd echo hello from scheduled task on %computer name %caret c:\temp\task_output txt c:\temp\remote_task. Simd echo execution time %date %time %caret c:\temp\task_output txt c:\temp\remote_task to cmd. Copy the batch file to the remote computer. Copy c:\temp\remote_task cmd //test01 $. Create a scheduled task to run every 5 minute test tasks /create /stestserver01 /tn test task /trc /temp\remote_task cmd /sc minutes/mo5/ru system. Check task details. Batch. Copy. tasks/query/stestserver01 /tn test task /v/fo list. Run the task immediately. Batch. Copy. tasks/run/stestserver01 /tn test task. After a few moments, check the output. PowerShell. Copy. Invoke command computer name testserver01. Script block if test path c:\temp\task_output txt right parenthesis left brace get dash content c:\temp\task_output txt else right output file not found. Task may not have run yet. Cleanup. Batch. Copy. tasks/delete/stestserver01 /tn test task /f. Expected outcome. You should be able to create, view, run, and delete scheduled tasks on a remote computer. Exercise 9. Network configuration with NetSH. Objective. Use NetSH to query and configure network settings remotely. Steps. Display IP configuration. Batch. Copy. NetSH test server 01 interface IP show config. View firewall settings. Batch. Copy. NetSH test server 01 add firewall show all profiles. Create a temporary firewall rule. Batch. Copy. NetSH test server 01 add firewall add rule name equals test web server. DR equals an action equals allow protocol equals TCP local port equals 8080. Verify the rule was created. Batch. Copy. NetSH test server 01 add firewall show rule name equals test web server. Delete the test rule. Batch. Copy. NetSH test server 01 add firewall delete rule name equals test web server. Expected outcome. You should be able to view network configuration and manage firewall rules on remote servers using NetSH. Exercise 10. Advanced multi-tool scenario. Objective. Solve a complex problem using multiple remote management tools. Scenario. A web application is not accessible. You need to diagnose and fix the issue remotely. Steps. Check basic connectivity. PowerShell. Copy. Hashtag test if the server responds to ping test connection computer name web server 01. Count 2. Check the web service. PowerShell. Copy. Hashtag use PowerShell remoting to check IIS service invoke command computer name web server 01. Script block get service name W3SVC select object name status start type. If the service is stopped, start it. PowerShell copy. Invoke command computer name web server 01. Script block start service name W3SVC. Check firewall status. Batch copy. Netchar web server 01 add firewall show all profile state. Ensure HTTP port is open. Batch copy. Netchar web server 01 add firewall show rule name equals allfinster/i80. Check disk space. PowerShell copy. Invoke command computer name web server 01. Script block get PS drive PS provider file system where object $_ name EQC select object name and name equals free GB. Expression equals math : round $_ free/1 GB 2 at name equals free %. Expression equals math : round $_ free/$_ used plus $_ free asterisk 102. Check event logs for errors. PowerShell copy. Invoke command computer name web server 01. Script block get event log name system. Entry type error newest 10. Look for application specific errors. PowerShell copy. Invoke command computer name web server 01. Script block get event log name application. Entry type error newest 10. Check IIS logs. PowerShell copy. Invoke command computer name web server 01. Script block get child item path C /in netpub /logs /log files. Recurse file sort object last write time. Descending select object first 1 get content tail 20. Restart the web application pool if needed. PowerShell copy. Invoke command computer name web server 01. Script block import module web administration restart web app pool name default app pool. Expected outcome. You should be able to diagnose and resolve the web application issue using multiple remote management tools and techniques. Comprehensive exercise. Server health dashboard. Objective. Create a PowerShell script that builds a dashboard report of server health metrics across multiple systems. Steps. Create a PowerShell script named getServerHealthReport.ps1. PowerShell copy. Run the script against your test servers. PowerShell copy. /getServerHealthReport.ps1. Computer names test server 01, test server 02. Open the generated HTML report. PowerShell copy. Invoke item C:\temp /serverHealthReport.html. Expected outcome. You should have a comprehensive HTML report showing the health status of multiple servers, including system information, disk space, process usage, service status, and recent errors. Extended challenges. Once you've completed the basic exercises, try these more advanced challenges. Automated software deployment. Create a script that deploys an application to multiple servers, checking prerequisites and validating the installation. Bulk user account management. Write a script.
So let's continue, guys, the answer.
Script to create, modify, or disable user accounts across multiple domain controllers. Multi-server patching. Create a solution to check for updates, install them, and report on the status across multiple servers. Configuration compliance check. Develop a script that verifies systems against a baseline configuration and reports discrepancies. Remote event log analysis. Build a tool that collects and analyzes event logs from multiple servers, identifying patterns and potential issues. Practicing these exercises will give you hands-on experience with the remote management tools and prepare you for real-world IT administration tasks. Start with the basic exercises and progressively work your way up to the more complex scenarios.
So as you can see, guys, this is our very good exercises. I have already all of these scripts that are already added or was explained. All of this I have already. If you open my Telegram channel, if you, this is my Telegram channel, if you go, you will see I have already exported these scripts. Let me show you where you can get them exactly. So here you go. This is, you get Windows Remote examples. This is an MD or this is extension marker or something, extension called mark D or something. This is remote management lab guide. You have remote Windows exercises. This is the one that you're talking about now, or we'll explain it now. And we will have the learning dialogue. This I will explain it with God will in a couple of seconds. So all of these you can get them, including the scripts and everything. You can get them from my Telegram channel, IT Visualizer. You can get all of these. So this is it. If we go and explain the guide or the learning dialogue, if we go, let me wait for a moment. This is the learning dialogue. Okay, let me show you. This is a learning dialogue. Okay, how we can or learn about the different tools, and this is how you can implement what was discussed in the learning dialogue. This is the learning dialogue. Let me try to read it out loudly, but let me do something here to make it more visible. We can share it, and then we can share, and then I can copy the link. Let me try to read it out loudly. Here you go. Let's go and read it out loudly. Okay, so let's show the content. Here I need to read only this one, okay, but not the whole thing. Anyway, so let me try to read it from there. Here is the dialogue itself. Try to read it out loudly. Okay.
The Machine Whisperer and the Visual Thinker. A dialogue on remote Windows management. Characters. Victor, a 58-year-old veteran system administrator with salt and pepper hair and perpetually oil-stained hand from his weekend classic car restoration hobby. Known for explaining everything through car mechanics analogies. Started his career with Windows NT and has survived every Windows disaster since. Measures work in cups of coffee and has an almost supernatural ability to diagnose issues by listening to the machines. 2 weeks away from semi-retirement. Maya, a 29-year-old former graphic designer who switched to IT for stability after the pandemic. A visual thinker who takes color-coded notes on a digital tablet and creates mind maps for complex concepts. Struggles with command syntax, but excels at pattern recognition. Working on automating her smart home as personal practice. Eager but sometimes overwhelmed by IT's vastness. Scene 1. The Hook. The IT department at Meridian Healthcare Systems. Monday morning, 7:30 a.m. Victor is already at his desk, on his second coffee, staring at multiple monitors. Maya arrives, her tablet tucked under one arm, a large tea in the other hand. Victor, without looking up, Terminal Server 4 is down. The accounting department starts their week in 90 minutes, and if it's not up, payroll processing stops. No remote desktop access. No physical access either. It's in the downtown data center, and there's road construction blocking the entrance. Maya, setting down her tea. Good morning to you too, Victor. Wait, Terminal Server 4? That's the one running those legacy finance applications, right? The ones that only work on Windows Server 2016? Victor nods, the very same beast. 200 users, one cranky server, and exactly looks at watch. 88 minutes until the finance director starts calling. This, Maya, is why I've been trying to teach you about remote management. When you can't touch the machine, you need to reach out and touch it without touching it. Maya opens her tablet. I've been studying the tools you mentioned, but I haven't had to use them in a real crisis yet. Victor turns his chair to face her. Well, today's your lucky day. Consider this your final exam before I head off to part-time consulting. 2 weeks from now, when some server decides to have existential crisis at dawn, it'll be your problem to solve from wherever you are. Maya swallows nervously. No pressure or anything. So where do we start? Ping the server? Victor chuckles. Ping is like tapping the hood of a car. It tells you if the car exists, not what's wrong with the engine. We need to get under the hood remotely. Let's start with the basics. Can we establish any kind of connection? Scene 2, the foundation. Victor, typing. PowerShell is your Swiss Army knife for remote management. Think of it as having a complete toolbox that you can instantly transport to any machine on the network. Maya, taking notes on her tablet. So it's like remote hands that can reach into the system? Victor, exactly. First, let's see if we can even establish a basic connection with PowerShell remoting. PowerShell. Copy. Test WS man computer name TS04. The command returns an error. Victor. No response. That means the WinRM service might be down or blocked. WinRM is like the doorman of remote management. If he's not at his post, we can't get in through that entrance. Maya, making a quick sketch on her tablet. So WinRM is like a portal that needs to be open on both sides? What are alternatives if that door is closed? Victor, good thinking. There's always more than one way into a car with locked keys. Let's try PsExec. It uses different protocols. Think of WinRM as the front door and PsExec as the service entrance. Copy. Sexec //TS04. umeridian /admin. psecurepass 123 CMD. Another error appears. Victor, well, that service entrance is also locked. Let's try another approach. Remember our remote management toolbox? Maya, consulting her notes, we have PowerShell remoting using WinRM, PsExec, safe for newer Windows servers, WMI/WMC, remote registry tools. Oh, and those command line utilities like SCEXE and Stasks. Victor smiles, good memory. Think of these as different roads to the same city. If the highway is closed, we try the back roads. Maya, so which back road should we take? Victor, let's try WMIC. It's an older tool, but sometimes the vintage approaches work best. Like using a mechanical ignition when all the fancy electronic starters fail. Copy. Mix/node, TS04/user. Meridian /admin/password. SecurePass 123 OS get status. The command produces output. Copy. Status OK. Maya, excited it worked? The server is responding to WMIC. But wait, it says the status is OK. If the server status is OK, what's the problem? Victor, nodding appreciatively, good observation. OK, just means Maya, visualizing. So the engine is running. Victor, nodding appreciatively, good observation. Okay, just means the operating system is running. The car's engine is on. But that doesn't mean all the components are functioning correctly. The server is alive, but something's preventing remote desktop connections. Maya, visualizing. So the engine is running, but maybe the transmission isn't engaging? Victor, chuckles. I think my car metaphors are rubbing off on you. Yes, exactly. Now I need to dig deeper. Scene 3. The challenge escalation. Maya, thinking, if the server is running, could it be a problem with the remote desktop services? Victor, good instinct. Let's check if the service is running. Copy. Mix/node, TS04/user. Meridian /admin /password. Secure pass 123 service where name equals term service get state. Output appears. Copy. State running. Victor. So the remote desktop service is running. The plot thickens. Maya. Drawing connections on her tablet. Could be a network issue then? Maybe a firewall rule got activated or the network configuration changed. Victor raises eyebrow, impressed. You're thinking like a troubleshooter now. Let's check the firewall status with Netch. Copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 process call create. Netch add firewall show all profile state. The command executes but doesn't show output. Victor, WMIC can run the command but doesn't show us the output. This is why having multiple tools matters. It's like having both metric and standard wrenches in your toolbox. Maya, puzzled. So how do we see what's happening with the firewall? Victor, time to try another approach. Let's use PowerShell's invoke command through WMIC. It's a bit like hot wiring a car when you can't use the key. Copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 process call create PowerShell command /getnet firewall profile select object name enabled format table auto-size c:\temp /firewall.txt / copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 process call create command exe/ctype c:\temp /firewall.txt. Output shows the firewall is enabled on all profiles. So the firewalls are on. Could they be blocking RDP traffic? Victor, that's our leading theory. Now we need to check the specific firewall rules for RDP. Maya, scrolling through her notes. Wait, can we check the RDP port directly? I remember TCP 3389 is the standard port. Victor nods approvingly. Great recall. Let's check if anything is listening on that port. Copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 process call create PowerShell command /getnet TCP connection. Local port 3389 format table. Auto-size c:\temp /port.txt / copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 process call create command exe/ctype c:\temp /port.txt. No output is returned. Victor, now we're getting somewhere. Nothing is listening on port 3389. That's like having a car with no one in the driver's seat. Maya, thinking. So either the RDP service isn't actually running correctly or it's running on a different port. Victor, checks watch. We're down to 65 minutes. Let's check the remote desktop endpoint configuration. Scene 4, guided practice. Victor, Maya, I want you to take the lead now. How would you check the detailed configuration of the remote desktop service? Maya, thinking, let me try using WMI to check the service in more detail. Copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 path when 32_ terminal service setting get/all. Output shows RDP is enabled, but there's an error code. Maya, studying the output, it says it's enabled, but there's an error code in the status. Let me check the registry settings for the service. Victor, nodding good approach. The registry is like the car's computer. It stores all the critical settings. Maya, types command. Copy. Mix/node ts04/user. Meridian /admin /password. Secure pass 123 process call create reg query /HKLM /system current control set backslash control backslash terminal server backslash slash v fn its connections. Output shows fn its connections equals 1. Maya, eyes widening, look. The registry key fn its connections is set to 1. That means our DP connections are explicitly denied. Victor, smiling proudly, excellent work. You found the culprit. It's like discovering someone pulled the fuel line. Now, how would you fix it? Maya, confidently. We need to change that registry value to 0 to allow connections. Copy. Mix/node ts04/user meridian /admin/password secure pass 123 process call create reg add /hklm /system /current control set /control /terminal server /v fn its connections /t reg_d word /d0/f. Command executes successfully. Maya, now we need to restart the terminal services service to apply the change. Copy. Mix/node ts04/user meridian /admin/password secure pass 123 service where name equals term service call stop service. Copy. Mix/node ts04/user meridian /admin/password secure pass 123 service where name equals term service call start service. Victor, nodding, very good. Now let's verify the port is listening. Maya, types command. Copy. Mix/node ts04/user meridian /admin/password secure pass 123 process call create PowerShell command /get net TCP connection local port 3389 format table AutoZyze c:\temp /port 2.txt /. Copy. Mix/node ts04/user meridian /admin/password secure pass 123 process call create command exe/ctype c:\temp /port 2.txt. Output shows the service is now listening on port 3389. Maya, triumphant. It's working. The RDP service is now listening on port 3389. Victor checks watch, and with 45 minutes to spare, let's verify we can actually connect now. Victor attempts to connect via RDP and succeeds. Victor, we're in. But the real question is, how did that registry setting get changed in the first place? Scene 5. The complexity crucible. Maya, thinking, let's check when the registry value was changed and by whom. Victor, good idea. How would you approach that? Maya, pauses. I don't think we can see when registry values were changed directly, but we could check the event logs for any registry changes or system modifications. Copy. Mix/node ts04/user meridian /admin/password secure pass 123 process call create PowerShell command /get event log log name system newest 100 where object $_ source EQ Microsoft Windows group policy format table time generated entry type source message AutoZyze c:\temp /events.txt / Copy. Mix/node ts04/user meridian /admin/password secure pass 123 process call create command exe/ctype c:\temp /events.txt. Output shows group policy changes were applied at 2 a.m. Maya studies the output. Look, there was a group policy update at 2 a.m. That must have changed the RDP settings. Victor, impressed, excellent detective work. Now I need to find out which policy is changing this setting. Maya, Can we check the effective group policy settings remotely? Victor, yes. Let's use the invoke command via WMIC again. Copy. Mix/node ts04/user meridian \admin/password secure pass 123 process call create PowerShell command \get resultante fallacy report type HTML path c:\temp\gp result HTML \. Command runs for a while. Victor, that will generate a detailed report, but it might take a few minutes. In the meantime, let's create a temporary solution to prevent this from happening again before we find a root cause. Maya, thinking we could create a scheduled task that checks and fixes this setting every hour. Victor, impressed. Now you're thinking like a systems administrator. Let's do it. Maya starts typing. Copy. Mix/node ts04/user meridian \admin/password secure pass 123 process call create PowerShell command \$action equals new scheduled task action execute PowerShell.exe argument no profile window style hidden command \set item property path \_hklm \system \/ current control set \/ control \/ terminal server \/ name \/ fnits connections \/ value 0 \. Dollar trigger equals new scheduled task trigger once at get date repetition interval new time span hours 1 register scheduled task action $action trigger $trigger task name \/ ensure RDP enabled \/ description \/ ensures RDP connections are allowed \/ user \/ system \/ run level highest force \/ Victor, checking the command. That's quite a complex command, but it should work. Now I need to verify the task was created. Copy. Mix/node ts04/user meridian \admin/password secure pass 123 process call create tasks/query/tn ensure RDP enabled \v/fo list c:\temp\task.txt copy. Mix/node ts04/user meridian \admin/password secure pass 123 process call create command exe/ctype c:\temp\task.txt output confirms the task was created successfully. Maya, perfect. Now let's check if that GPO report is ready. Copy. Mix/node ts04/user meridian \admin/password secure pass 123 process call create PowerShell command \if test path c \temp \/ HTML write output report is ready else write output report still generating \. Output shows the report is ready. Victor, now we need to get that report to our local machine for analysis. This is where file transfer comes in. Scene 6, the integration. Victor, we need a way to copy that file back to our workstation. Let's use PowerShell remoting now that the WinRM issue is fixed. PowerShell, copy. #enable PowerShell remoting again now that RDP is working. Enable PS remoting force create a remote session $session equals new PS session computer name TS04. Credential, get credential. #copy the file from the remote server copy item path C \temp \presult HTML destination C \users \victor \desktop from session $session. They open the report and analyze it. Maya, pointing at the screen, there it is. The terminal services security policy is set to deny RDP connections. It's coming from the server lockdown policy object. Victor nods, mystery solved. That policy was designed for our high-security database servers, not terminal servers. Someone must have accidentally added TS04 to the wrong security group. Maya, let me fix that. Maya accesses the Group Policy Management Console and removes TS04 from the high security group. Maya, proudly, I've removed it from the wrong group, but we should keep our scheduled task running until the next group policy refresh cycle, just to be safe. Victor, smiling, excellent work, Maya. You've not only solved the immediate problem, but also identified and fixed the root cause, all without leaving your desk. Maya, looking thoughtful. This was actually kind of amazing. We diagnosed and fixed a server problem using nothing but command line tools, working completely remotely. It feels like having superpowers. Victor, that's exactly what remote management is, IT superpowers. When you can control hundreds of servers from anywhere, you become much more than just one person. Maya, taking notes. So for future reference, our troubleshooting path was: try PowerShell remoting, failed. Try PSExec, failed. Use WMIC to verify the system was running. Check service status with WMIC. Use WMIC to execute local commands. Find a registry issue. Fix the setting and restart the service. Find a root cause in group policy. Create a safety net with a scheduled task. Fix the group policy assignment. Victor, nodding, and we used multiple tools: WMIC, PowerShell commands via WMIC, registry commands, and scheduled tasks. It's like having different tools for different parts of the car engine. Maya, smiling. I think I'm ready for when you move to consulting. But I'd like to set up a practice lab so I can get more familiar with all these tools. Victor finishes his coffee. That's an excellent idea. Let's build you a lab environment this afternoon. In this business, you need to practice fixing things before they break in production.
So as you can see here, this is a very good case, and here is the hands-on lab, how you can set up a lab to exercise all of these scripts. And actually all of these are already in my uh, uh, my Telegram channel. Here we can see here is the remote management dialog, and this is the lab guide, and this is the exercise. So this is the dialogue, and this is how you can practice what was said in the dialogue in a lab. And then this is the hands-on exercises that we have discussed today. And all of these are just examples how we can use different remote tools to solve problems concerning Windows. Hope this video informative for you all, and thank you all for viewing. Until the next video, thank you so much. With God will. Thank you.